Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about how to find the equations of tangent and normal lines to curves. So if you're asked to find the equation of a line tangent to a curve at a certain point, for example, let's say we want to find the equation of the line tangent to the curve at this point. Remember that the tangent line only touches the curve at that point. It does not pass through the curve. And remember that the slope of the tangent line is the same as the slope of the curve, and both of those are equal to the derivative. So we can find the slope of the tangent line by finding the derivative at that point. And we need two pieces of information to find the equation of a line. Remember that the equation of a line looks like this: y equals mx plus b, where m represents the slope and b represents the y-intercept. So that's where the line crosses the y-axis. It's the value of y when x is 0. So we want to get our equation and put it in this form. We need more than the slope. We also need a point. So if we're told the point, we can put the point, the values of x and y into this. We put the slope in, find our y-intercept. Once we have slope and y-intercept, we have the slope-intercept form of a straight line. If we're asked to find the equation of a line normal to a curve, a normal line is perpendicular to the curve. So a normal line would form a right angle with the tangent line at that point. Because it's perpendicular, we also have to recall the relationship between the slopes of perpendicular lines. And that relationship is the slope of one will be the negative reciprocal of the other. So that means the slope of our normal line will be the negative reciprocal of the slope of our tangent line. Whether we're finding the equation of the tangent line or the normal line, we're going to start the same way. We're going to find the slope by finding the derivative, and then we're going to use that slope and a point to find the equation. Let me show you how. If we were asked to find the equation of a line tangent to this curve, y equals x squared minus 2, at x equals 1, what I would do first is I would find the slope at that point. So at x equals 1, I can find the slope by finding the derivative. So my derivative will be 2x. At x equals 1, the derivative will be 2 times 1. Therefore, the slope of the tangent line will equal 2 times 1, which is 2. So we've got the slope of our line. We need a point. We were only given the x value, so we need to find the y value. So at x equals 1, y will equal 1 squared minus 2. So y will equal 1 minus 2, which is negative 1. So my point is 1, negative 1. The slope is 2, and those are the two pieces of information I need to find the equation of my line. There's different ways that you can find the equation of the line. You can use point-slope form of the straight line. That's fine. I'm just going to use the slope-intercept form. So I plug in my y value is negative 1. My slope is 2. My x value is 1. And I find b. So I'm going to subtract 2 from both sides. So b will equal negative 3. Now that I've got b and m, I've got the equation of my line. So y will equal 2x minus 3. That would be the equation of the line tangent to that curve at that point. Let's do this same question, but this time we're going to find the equation of the line normal to the curve. So we're going to find the equation of the normal line. So in order to find the equation of the normal line, I'm going to start off exactly the same way. I'm going to find the derivative and evaluate it at the point. That will be the slope of the tangent line. Then, instead of using that slope, I'm going to take the negative reciprocal. So the slope of the normal line will be negative 1/2. I'm going to find the y value at x equals 1 because that's the same point. And now I'm going to use this slope and this point to find the equation of my line. So I plug my y value into this form of a straight line, negative 1 equals my slope, which is negative 1/2, times the x value plus b. I'm going to add a 1/2 to both sides, and I will get negative 1 plus 1/2 is negative 1/2. Once I've got the slope, and once I've got the y-intercept, which just happen to be the same, coincidence, I can plug those values into my equation. So y will equal negative 1/2 x minus 1/2. So that's the equation of the normal line. Let's take a look at a few more examples. In the next example, we're asked to find the equation of a line tangent to the curve x squared plus y squared equals 25 at the point 3, 4. So if we were to draw this, it would just be a circle. And so we're trying to find the slope of the tangent line in order to find the equation of the tangent line at that point. To find the slope of the tangent line, we find dy dx. We are able to differentiate this implicitly because we've learned that in a previous video. We differentiate each term with respect to x. So the derivative of the first term is 2x, plus the derivative of y squared would be 2y to the 1 times dy dx equals the derivative of 25, which is 0. Now we're going to solve for dy dx. We'll subtract 2x from both sides. Now we'll divide by 2y. And we'll simplify by canceling the 2, the factor of 2. So we know that our derivative is negative x over y. So we're going to find that at our point. So at our point 3, 4, the derivative will equal negative 3 over 4. So therefore the slope of the tangent line will equal negative 3 over 4. So we use that slope and this point to find the equation of our line. Plug in our y value of 4, our x value of 3, and solve for b. So that will be negative 9/4. And when we're adding 4 plus 9/4, remember you need a common denominator, so that's like 4 over 1. So that will be 16 over 4 plus 9 over 4, which will be 25 over 4. Once we have m as well as b, we have the equation of our line. So our equation will be y equals negative 3/4 x plus 25/4. I like leaving it in that form. Sometimes people will multiply through by your lowest common denominator to get rid of the fractions and write it in general form. But I like this because it tells me quite a bit of information about that straight line. Let's take a look at one more example. Our last example is a little bit different. It asks us to find the equation of the line tangent to the curve y equals 1/2 x to the 4th plus 1 if the tangent line has a slope of negative 16. So instead of telling us the point, it's not telling us the x value, it's telling us already what the slope of the tangent line is. So we know that. And remember, to find the equation of any line, we need a point and the slope. So what we need to do is find the point. We're going to start off by finding the derivative. 1/2 times 4 is 2, x to the power of 3 plus 0. And what we want to do is find where this is equal to negative 16. So we put a negative 16 in for the derivative, which is the same as the slope of the tangent line. And we solve for x. Divide by 2 take the cubed root of both sides, so x will equal -2. So we're finding at the x value, x equals -2. We need to know the y value. So at x equals -2, y will equal 1/2 times -2 to the 4th power plus 1. -2 to the 4th power is 16. 16 times 1/2 will be 8. 8 plus 1 is 9. So now we've got our point as well as our slope. So we can find our equation. Plug into this form, or you can plug into slope point form of a straight line, and we'll get 9 equals -16 times -2 plus b. That gives us 32 plus b. So b will equal, subtract 32 from both sides, and we'll get -23. Once we've got b and m, we have the equation of our line. So y will equal -16x minus 23. That's the equation of the tangent line to this curve, and it would be at this point. So at -2, 9, we just found the equation of that tangent line. One word of caution, when you hear slope of a tangent line and equation of a tangent line, they're two different things. Often when I would ask students just to find the slope of a tangent line, they'd give me the equation. If you're just asked for slope, just find slope. You go to these next steps if you're asked to find the equation. So just read it carefully. Whenever you're asked slope of a tangent line, instantaneous rate of change, or derivative, you're doing the same thing. You're finding the derivative. But if you're asked for the equation, you have to go a little bit further to find the actual equation of a straight line. Practice these, and when you're ready, move on to the next video. Take care and see you then.